students. Today's our topic is de Broglie wave. What is de Broglie wave? According to de Broglie, with a moving material particle, there is always a wave is associated with it. This wave is also known as matter wave or de Broglie wave. The waves associated with the moving material particles are known as de Broglie waves or matter waves. With the uh, moving particle, there is always a wave is associated. This is the observation of the de Broglie, as well as he experimentally explained this. Now, he have also given an expression for the de Broglie wave. Let's see. According to quantum theory, according to quantum theory, what is according to quantum theory, light always travels in the form of photons. So from the quantum theory, the energy of the photon, that is E equals to hc upon lambda. So mark it first equation. Now according to Einstein's theory, the energy of the photon, Einstein's mass energy relation, E equals to mc square. So from here we can see the left hand side and right hand side. Left hand sides are equal, that's why right hand side we can equate the right hand side. So from here c and c cancelled out, we got mc equals to h upon lambda, and lambda equals to, we got h upon mc. Here we can write mc, where m is the mass of photon, c is the speed of light, h is the Planck's constant. So momentum is equals to mass into velocity. So here this is the mass of photon, this is velocity of photon. That's why this is the momentum of the photon, that is represented by p here. Here where the p equals to mc, that is the momentum of a photon. Now if instead of a photon we have a material particle, in place of the photon, if we are interested to discuss about the material particle, so in case of the material particle, if we have a material particle of mass m moving with a velocity v, then the equation becomes, momentum p equals to mass into velocity. That's why in place of the p we can place here uh, m into v, that is the momentum of a material particle. In case of the photon, this will be m into c, because of photon always travels with the speed of light. Now this lambda equals to h upon mv, or we can write also lambda equals to h upon p, where p is the momentum of any material particle. This is the expression for de Broglie wavelength for any material particle. Now what are the conclusions which are given by de Broglie? First conclusion, de Broglie wavelength, from here, from this expression lambda equals to h upon mv, from this expression we can observe the de Broglie wavelength is inversely proportional to the velocity of the particle. It means if the particle moves faster, velocity of the particle is high, then the wavelength of the particle, wavelength of the wave associated with the moving particle will be smaller, and vice versa. Second conclusion we can draw from this expression, if the particle is at rest, means the velocity is zero. If the velocity is zero, then this wavelength will be, de Broglie wavelength will be infinite. Such wave cannot be visualized. The wave of de Broglie wave of wavelength infinite, that this kind of waves cannot be visualized. Now third one, from this expression you can see the de Broglie wavelength is inversely depends on the mass of the particle. The wavelength associated with the heavier particle will be smaller, and for the lighter particle will be uh, higher. So this is the conclusion from this expression. Now fourth one, de Broglie wavelength is independent of the charge of the particle. From this expression you can see there is no term of charge of the particle. That's why the de Broglie wavelength is independent of the charge of the particle. Matter waves, because of these de Broglie waves, or we can say matter waves, and these matter waves are not electromagnetic waves. These are mechanical waves. These are not uh, these are not electromagnetic waves because they are not produced by accelerated charge particles, because electromagnetic waves always produced by accelerated charge particles, but matter waves or de Broglie waves cannot be produced by accelerated charge particles. Along with this, matter waves, also known as probability waves, because of the amplitude of which gives the amplitude of these waves gives the probability of existence of the particle at that point. As we have discussed in the diagram, here the particle, this is the position of the particle and the amplitude of the wave. This will gives the probability of the existence of this uh, particle. So this is the complete explanation of de Broglie hypothesis and the de Broglie wave, or we can say the matter wave. Thank you.